Hello everyone, welcome back to my video. So today we are going to continue with our chemistry form 4 chapter 5, and now we are going to do part 3. So before we move on to the part 3, let's do a little recap of part 2, which is our previous video or our previous part of this chapter. Alright, so let's start with the basic. We have chemical bond, which is the main topic of this chapter. Okay, under chemical bond, in the previous video we learned about non-metal elements. Okay, so what we know about non-metal element is that they share electrons. They do not transfer electrons, unlike ionic bond. Okay, so when non-metal elements share electrons, it will be called as covalent bond. Alright, so under covalent bond, there are three types of bonds. Okay, so covalent bond is defined as when the electrons are contributed by both atoms. Okay, so the three types of covalent bond is if there is a one pair of electrons that are shared between both atoms, it is called as single bond. Meanwhile, if there are two pairs of electrons shared by both atoms, it will be called as double bond. And lastly, if there are three pairs, it will be called as triple bond. Very simple. Okay, next, either if there is a one pair, two pairs, or three pairs are shared between both atoms, it will form covalent compound. Okay, when both atoms share their electrons, it will form covalent compound, such as like this diagram. This is a covalent compound of water, H2O. Okay, so as you can see here, there is single pair of bond shared between hydrogen atom and oxygen atom. Okay, this is what I meant about the single bond. There is one pair of electrons shared between the two bonds, I mean the two atoms. And then this is the double bond. This is one pair, and then the second pair. And the third bond is this one second, and the third bond. So that is how we classify it as single, double bond, and triple bond. Okay, so we have done our recap, so let's jump into the part 3 of this chapter. Now we are going to talk about hydrogen bond, which is an attraction forces between hydrogen atom and an atom of high electronegativity from another molecule. Okay, so it is very simple. You just need to remember phone, which is F-O-N. Okay, what does phone stands for? For F is it stands for fluorine, and for O is oxygen, and lastly N is for nitrogen. These three are the atoms with high electronegativity that will form hydrogen bonds with hydrogen atom. Okay, so let's look at the example, which is the formation of hydrogen bonds between water molecules H2O. So now we have water molecules right here. This is the water molecule of water. Okay, so how the hydrogen bonds are formed. Okay, firstly, like I said before, phone, which is fluorine, oxygen, and nitrogen. So we can see here, we have oxygen here, which is a high electronegativity atom. And then how does hydrogen bond is when the oxygen atom forms an attraction force with the hydrogen atom. Therefore, it will form hydrogen bond. So basically, the hydrogen bond must occur between two molecules or more. Okay, hydrogen bond cannot form in the molecule. It must be with other molecule. So this is the first molecule and the second molecule. So oxygen atom of the first molecule form hydrogen bond with the hydrogen atom in the second molecule. You get me? Okay. So yeah, this is very basic. We all learned in the previous video, which is the covalent bond, and it is a sharing of electron between non-metals. That is why I said that hydrogen bond can only occur between molecules. It cannot occur in the molecule, okay? Because this is one molecule. So that is why this hydrogen and this oxygen is called covalent bond. It's not hydrogen bond. Okay, so let's move on to the role of hydrogen bonds in our daily life. We see here that in our daily life, we often shower, we often wash our hair, right? So if you guys notice, obviously you guys notice that our hair sticks together when our hair is wet. But when our hair is dry, it does not stick to each other. Why? Okay, this relates to the hydrogen bond between molecules. So we have here is a dry hair. Okay, this is the dry hair. Firstly, we know that our hair does not stick to each other. It is because the protein molecules of our hair, which is keratin, form hydrogen bonds among themselves. Okay, so this image shows that this is our hair when it is dry. So you can see that it does not stick to each other. Okay, the protein molecules form hydrogen bonds between each other. This is the first protein molecules, and this is like the second protein molecule. So they form the hydrogen bonds between each other. Okay, so it kind of like repel each other. You get what I mean? So that is why it does not stick to each other. Meanwhile, if our hair is wet, the protein molecules no longer form hydrogen bonds among themselves. It's because when it is in contact with water, the protein molecules of our hair will form hydrogen bonds with the water. So that is why our hair sticks. Okay. So when the water molecules do when the protein molecules of our hair form hydrogen bonds with the water molecules, this is the hydrogen bond, and this is the water molecule, right? So this is our hair proteins. Yeah. So basically, it forms a hydrogen bonds with the water molecule. Therefore, the water is kind of like pulling our hair protein molecules together. So that is why it sticks. Okay, it's like pulling in instead of our hair when it's dry. It's like repelling each other's. Okay, so that is like the general view of our hair when it's dry and when it is wet. Okay, so now that we know the one example of the formation of hydrogen bonds in our daily life, so now let us know about the effect of hydrogen bonds on the physical properties of substances. So my first example is for boiling point. We have ethanol here, the substance that I will be using as our example. So for ethanol, there are two types of attraction force. Okay, the first one is hydrogen bond, and the second one is the van der Waals force. So basically in ethanol there are two types of attraction force, which is hydrogen and van der Waals force. For hydrogen bond, we are considered it as a strong attraction force. Meanwhile for van der Waals, it is a weak attraction force. But for this chapter, we are only going to more focus on the hydrogen bond. Okay, so for hydrogen bond, since it is a strong attraction force, it is very difficult to break compared to compared to van der Waals force. Therefore, when we heat up a substance, which is the ethanol that we are using as an example here, it needed heat energy to overcome the hydrogen bond and the van der Waals force. Okay, so when there are two attraction force that are needed to be broken down, more heat energy required to break down or to overcome both of these attraction force. Okay, so when we need more heat energy required to overcome, which means we have to make the fire, or we have to heat it up more to break down the attraction force. So it means that we have a high boiling point, which means the substance has a high boiling point. It is not easily melt, or it is not easily vaporized. Okay, so that is the effect of hydrogen bonds for boiling point. Okay, for our next effect of hydrogen bond on the physical properties of substances, we are going to talk about the solubility of substances in water. And again, we are going to use ethanol as our example for the solubility in water. Okay, so we have ethanol here. As you might know or not, ethanol is soluble in water. Why? So, ethanol is soluble in water due to the formation of hydrogen bonds between the ethanol molecule and water molecule, H2O. Okay, so you guys might be wondering, how does it forms hydrogen bonds? Okay, so let me show you a diagram of it, just for you guys to understand more clearly about how it forms hydrogen bonds with the water molecule. Okay, so now we see here, this is the ethanol molecules. Okay, there are two ethanol molecules, the first ethanol molecule and the second ethanol molecule. Okay, so as you guys still recall, I talked about the van der Waals attraction force before, right? So van der Waals occurs when there is an attraction force between molecules. Okay, so now we have like this attraction force between the first ethanol molecule and the second ethanol molecule. We call it as van der Waals attraction force. Okay, so let's not mind that too much, because we are going to focus on the hydrogen bonds only. Alright, so when ethanol is in the water, we want to test its solubility. And how does we test it? We can know that it forms hydrogen bonds with the water. Okay, so we have our molecule of ethanol here. Oxygen atom, O in ethanol molecule. This is the oxygen atom, and it will form a hydrogen bond with the hydrogen atom in the water molecule. So that is how the hydrogen bond forms here. And then another hydrogen bond can be formed when hydrogen atom is the ethanol molecules forms a hydrogen bond with the oxygen atom in another water molecule. So when the ethanol can form a hydrogen bonds with the water molecules, just as I've shown in this diagram, it means that it can it means that it is soluble in water. Okay, so you guys, so far so good. I hope you guys can catch up with what I've been explaining so far. So let's get on with our practice questions. So we have our first question. Hydrogen fluoride, HF, exists as a liquid at room temperature. So explain this phenomenon based on the formation of hydrogen bonds. Okay, so I've drawn a hydrogen fluoride molecules here. We have 3 hydrogen molecule. So let me explain a little bit to get you guys understand how the phenomenon of this of hydrogen fluoride exists as liquid at room temperature. Okay, so like I've mentioned before, when there is an attraction force between the molecule, it is called van der Waals force. Okay, therefore, if you guys recall, the high electronegative atoms are found, which is fluorine, oxygen, and nitrogen. What we have here is fluorine, which is a high electronegative atom. It is fluorine here from this molecule form a hydrogen bond with hydrogen atom in another molecule. So this attraction force is called hydrogen bond. Okay, so we can see here, this is related to it is similar to our example of ethanol for boiling point, very similar. So just repeat what I've explained earlier, which is a lot of energy required to overcome the attractive van der Waals force between hydrogen fluoride, which is this one, between hydrogen fluoride molecules, and then in addition to the hydrogen bonds. It means that we need a lot of heat energy required to overcome van der Waals force and hydrogen bonds. Therefore, the more that we need heat energy, the more that hydrogen fluoride has a high boiling point. And when it has a high boiling point, it exists as liquid at room temperature because, like I said before, it does not easily vaporize if it has a high boiling point. Okay, let's move on to our second question. Explain why paper sticks together when it is wet. So the concept is similar to our wet hair situation. So right here we have our paper cellulose molecule. This is the paper cellulose molecule, and this is another paper cellulose molecule. Okay, so you can imagine that when the paper is not wet, it will repel with each other. Okay, imagine this is the first molecule and the second molecule of paper cellulose. So when it bonds a hydrogen bonds between each other, it will sort of like repel each other, though it will not stick to each other. So in this diagram here, I've drawn here, this situation is when the paper is wet. So when the paper is wet, we have the water molecule here. So both of these paper cellulose molecule will form a hydrogen bond with the water molecule. Okay, so when it forms a hydrogen bonds with the water molecule, it sort of will form like how to say, it attracts to each other, so it will stick to each other when it forms a hydrogen bond with the water molecule. Okay, so I think my explanation before this might be a little bit fast or unclear to you, so let me explain again. Okay, so we have both of these paper cellulose molecule. This is the first one and the second one. Okay, so when both of these paper molecule form a hydrogen bonds here with the water molecule, it will attract to each other. so it's kind of like pulled in, so that's why the paper will stick to each other when it is wet. Okay, I think you guys can understand what I'm saying here. So let's move on to our last part of this video. So here we are at the summary of this video. Congrats. So now let's do some quick recap of this video. Okay, so in covalent compound, it is divided into two molecules, which is first the giant molecule, and the second one is simple molecule. So simple molecule is where we are more focused on in this video. So simple molecules have two attraction forces. The first one is the attraction force between molecules that we call as van der Waals force. Okay, and then the second attraction force, it occurs when hydrogen atoms form a hydrogen bond with a high electronegativity atom, which is fluorine, oxygen, and nitrogen. Okay, hydrogen. So when these two form a bond, it is called hydrogen bond. Okay, so literally, yeah, this is the same thing as I mentioned above. When hydrogen atoms form hydrogen bond with, when hydrogen forms an attraction force with either of these fluorine, oxygen, or nitrogen, it will form hydrogen bond. So this is where our video ends. Okay, I hope you guys understand what I've explained so far. Okay, so I'll see you in our next part of this chapter. See you guys again.